Hello everyone. In this video I'm going to talk about the web interface for the drip irrigation control system. So as you can see, here is the board on the left and two devices that are connected to the board. And as you can see, the time on all of these devices is the same. They're all synchronizing together because the board is sending out the time information to all the devices that are connected via WebSockets. Now if I make any changes to the state of the system that's synchronized across the devices. For example, if I turn on the sprinkler on my laptop, you will notice that the state has been synchronized across all the devices. So the board says the sprinkler is on and it shows the time for how long the sprinkler will run, and the phone shows the same information and the laptop also shows the same information. Now if I turn it on or turn it off on my phone, all the devices will show the new status, and this is all done through WebSockets. Another way we can synchronize all these devices is if I delete these schedules from my laptop and I click save, then you will notice that it has gone away in my phone as well as on the device. So that's how WebSockets is used to synchronize everything. I wanted to show you the web UI code that I used in the sprinkler system. So there are a bunch of files here: the countdown timer, sprinkler schedule, sprinkler web, and all of these. So this is the project that I use. I kept these files separate from the device's C++ code, because this way I can just change whatever I want in the web front end and then upload that code to the device, and the ESP8266 will then serve these files. And anytime I make changes to the web interface, I don't have to redeploy everything into the device along with the C++ code. So this is just web code that's sitting separate from the native code. So I don't want to go through all the JavaScript files here. I've used Node.js and lit.html to build the web page, and of course I've used Polymer, paper buttons and stuff to make to show all the fancy buttons and list boxes. But the important thing that I wanted to show you is that after I've wrote all the code and made any changes, I can use the rollup config to compile the code and convert them to simple HTML and JS files, minified ones. And this is the cleanup code that I wrote that will minify these files and rename the files a little bit so that they will all fit on the ESP8266 small memory space. Basically what this script does is it will switch to the web code, do a build, then go to the device's data directory from where it will be uploaded to the device, remove the old files, copy over the new web files from the web directory into the data directory, and then it will use platform IO to upload the file system files, which is the HTML static files, over the air. So I'll just show a quick demo here. So on the command line, I'm doing an export device sprinkler terrace, which means I'll be uploading this new web code to the sprinkler terrace device. I have multiple devices, each with their own name. So this one is called sprinkler terrace, and I'll run the script here. So as you can see, it will go to the web directory, build all the files, and then copy over the files into the device's data directory, and then upload them over the air. So this might take some time, so I'll stop the video here, but this is how I develop. So I can keep the native code and web code separate, and I can upload the codes independently, and I can work on different projects at different times. Thanks for watching.